All right, so we're going to try this. All right, so here we go. Let's match these. So I'm going to match by finding x-intercepts, all right? So the x-intercept is going to be 0 because, well, we'll just go on. So here we go. This is going to have an x-intercept of -2 and 0 because this binomial needs to be equal to 0, and I'll talk about that more later. So this has a x-intercept of -2 and 0. This one's going to have x-intercepts of -2 and -3. This one is going to be -3 and -3, so just one intercept of -3. This one's going to be 0 and +4, because 4 minus 4 is. And so +4. Where's it? Here we go. This one's going to be 0. X-intercepts are going to be 0 and 4, because 4 minus 4 is. It's going to be. This is 0 and -4. This one's going to be 0, -3, and this one's going to be +3. So here we go. All right. So here's how I was doing that so quickly. I'm looking at x-intercepts. I have the x-intercepts turned on. So here. So I know my x-intercept is going to occur when the graph comes to the x-axis. So this x-intercept is -4 and 0. X-intercepts here are 0 and 4. This one's going to be 0, right? -3 and -2. This one is going to be 0 and 4. The x-intercepts here are -3 and 3. The x-intercept here is just have 1 at -3. And here we have -2 and 0, right? So you'll notice that there is a connection between the factored form equation and the x-intercepts. Simple. You'll also notice, and I want to show this now, that the line of symmetry, there we go, the line of symmetry is always occurring halfway in between the x-intercepts. Always, always, and always. It happens on all of them. You can see that green line is right in between, or right, in the case when you only have one x-intercept, right in between the two red circles. The final thing I want to show you before we move on is that the minimum is always occurring on the always on the line of symmetry. So in other words, let me turn this stuff off. The factored form equations will give you the line of symmetry. Then the line of symmetry is going to help you get the minimum or the maximum. So that is going to be the order of things. And the expanded form will get you your y-intercepts. If you want to look at them, there they are. They're in orange. Okay, so here we go. So I'm going to take an equation of my own making. I'm going to say y is equal to x squared minus 8x, minus 10. I'm going to do minus 10. All right, so again, our strategy. Step 1, find the x-intercept. Step 2 is find the y-intercept. And I'm going to do this with the factored form equation. For the y-intercept, it's going to be the expanded form. And then, moving on, I'm then going to look for the line of symmetry, and then finally the minimum or the maximum. So, here we go. I'll make my little table of values that I'm looking for, the x-intercept, y-intercept, line of symmetry, and the minimum. This will have a minimum. It'll only have a maximum if the x squared value is negative, but you don't have to remember that for a while. So we need our factored form to get our x-intercepts. So do we have any greatest common monomial? We don't. Negative 10 is not a square. 10 isn't a square. Negative 10 certainly is not a square. So we don't have a difference of squares. We don't have a square binomial. So we have to find a binomial pair of factors. So we're looking for factors of negative 10 and a sum of negative 8. So then, factors of negative 10. Well, let's see. I know that my negative, I'm going to have a negative and a positive factor. And the negative one is going to be farther from 0 because that is a negative. So let's say negative 20 and 1. That has a sum of negative 19. Nope. No, negative 10 and positive 2. That has a sum of negative 8. That works. So the equivalent form is x minus 10 times x plus 2. So then, moving on, we have y is equal to x minus 10 times x minus 2 plus 2. And I'm going to find the x-intercepts with this. Now you'll remember that when we were on that previous page, we said that the x-intercepts always occur when our y value is 0. So I'll turn off these other things. And so you'll see that these x-intercepts are always occurring at y equals to 0. Because this line here, the y-axis, has a y value of 0. We're going to have to use that. So we have 0 is equal to, because y is always equal to 0, x minus 10 times x plus 2. Now I'm going to conceptually go through this first. We have two numbers. We have one number here. We have one number here. We're multiplying two numbers together and we're getting a product of 0. The only way to multiply two numbers together and get a product of 0 is if one of these two numbers is 0, which means this binomial or this binomial must be equal to 0. So x minus 10 has to equal 0. Well, what can we substitute in for x to make that 0? So 10 minus 10 is equal to 0. Therefore, this x must be 10. On our second binomial, 10 plus 2 is going to be 12, right? But it's not going to matter because 10 minus 10 is 0. 0 times 12 is 0. We get our 0. What can we substitute in for this x to make this binomial 0? Well, something plus 2 is 0. So negative 2 plus 0 is, negative 2 plus 2 is 0. And then negative 2 minus 10 is negative 12. Negative 12 times 0 is 0. So my x-intercepts are negative 2 and 10. So for the y-intercept is actually really simple because the y-intercept is what occurs when x is 0. So that would be 0, that would be 0. So the x-intercept will always be this constant, the c value. So whatever number in expanded form is off by itself, that's your y-intercept. Now for the line of symmetry, we will remember that we said that the line of symmetry occurs when right in between the two x-intercepts, right? So essentially we have to find the average of the two x-intercepts. So if I add the two numbers together, divide by 2, I'll get the line of symmetry. So we have negative 2 plus 10 over 2, because I'm dividing by 2. So we get 8 over 2 is equal to 4. So the line of symmetry is just x equals 4. Finally, you'll remember that when we looked at our graphs, so here's our line of symmetry, that the maximums or minimums only occur along that line of symmetry. So that means that the x value for your line of symmetry has to be the same as the line of symmetry. But that doesn't really help. Well, it does help a lot, but we still need to find this value. So when we're looking at the minimum or maximum, we're going to have to plug in our x value to find our y value for our minimum. So I'm going to say x is going to equal to 4, which is my line of symmetry. I'm going to use my factored form equation of y is equal to x minus 10, x plus 2. So let's plug in this for x. Y is equal to 4 minus 10 times 4 plus 2, 6. So I get negative 6 times 6. Negative 6 times 6 is negative 36. And there we go. Oops. Oh, come on. So my minimum is at 4 comma negative 36. And there we go. We have successfully found the 4 important points of the parabola. Now I'm going to try, I can show you a different one that sometimes trips people up. If I have an equation that looks like this, y is equal to, whatever, 6x squared plus, how about 24x? So again, we're going to look for the x-intercepts. That's going to be factored form. Y-intercept, expanded form, line of symmetry, and minimum. That's going to get a minimum again. So first thing I need to do is factor it, right? So look for greatest common monomial. Does something go into both of those terms? And yeah, it does. Well, 6x does. So this is going to be equivalent to 6x. We divide both of these by 6x. And so I'll get x plus 4. So 0, and this is for the x-intercept, 0 is equal to 6x times x plus 4. What's going to make this binomial 0? Well, something plus 4 is 0. Well, negative 4, of course. Then 6 times something has to equal 0. Well, 6 times something has to equal 0, therefore it just has to be 0. So we have 0 and negative 6. And this one here, what are we adding to this equation here? Well, we're adding 0. There you go. The line of symmetry happens halfway in between these 2 points. What's halfway in between 0 and negative 6? Well, negative 3. And for our minimum, it's going to be negative 3, comma. Okay. So let's plug it in. So we have x is equal to negative 3. And we have y is equal to 6x, x plus 4. So y is equal to 6 times negative 3 times negative 3 plus 4. 6 times negative 3 is negative 18. Negative 3 plus 4 is going to be 1. So y is equal to negative 18. And there we have it. So I've given you 2 examples of how to find the important points of a parabola given an equation. Obviously, I've given you equations in expanded form first. If you're given a factored form equation, you have to expand it. And so that's all you need to do.